If I were to ask you, what determines a 24-hour day? You would probably answer something along the lines of, well, the time it takes the Earth to rotate. And although you'd be fairly close, you would be wrong. So let me explain that. What we're actually talking about is a solar day versus a sidereal day. So a solar day is 24 hours. But let's understand the difference here. So the Earth travels or rotates once every day, and there's 365 days in a year. Well, if you think about the path of the Earth around the sun, it's 360 degrees that it traverses. So every day it moves around the sun about 1 degree. So that's the key to understanding what's going on here. A sidereal day is the time it takes the Earth to not orbit, but rotate once. And that's a little bit less than 24 hours. In fact, 4 minutes less. 23 hours, 56 minutes. So, what it's really defined by is when a view on Earth at one point in time is matched again by the view of the background stars. So, let's say that here we are, seeing a star up on the crossing our meridian at midnight. When the Earth orbits, I keep saying orbit, when the Earth rotates once, that same star will be at the meridian again. That's the time it takes to rotate once, and it's 23 hours, 56 minutes. There's the clock showing that time. So, that's a sidereal day, the time it takes to rotate one time. But oops, Earth is not lined up with the sun yet. So here the Earth lined up with the sun. As it rotates once, it's at this location, the same direction to the background stars, but notice that it's not lined up with the sun again. The Earth has to rotate a little bit more, an extra degree more, so that it's once again lined up with the sun. So that's a 4-minute additional amount of time, and that gives us a solar day, where a solar day is the time where, from an Earth point of view, the sun is in alignment from the day before till the current day. The sun is in alignment again, and that's 24 hours exactly. It's where the sun crosses the meridian at solar noon at our location. So, just to clarify, the solar day, the time where the sun crosses the meridian, 24 hours later it will cross the meridian again. But the Earth has rotated 360 degrees plus another degree, about 361 degrees. And that's what 24 hours is based on. Well, let's once again consider how the sun moves along the celestial sphere, particularly along the ecliptic, as the Earth orbits the sun. So it's the passage of the sun through the background constellations. It's an equivalent way to express it. We know that the stars we see from the point of view of Earth changes as Earth orbits the sun. And of course it makes a lot of sense because we're looking at the constellations on the other side of the sun. We look out in the night sky, and as we orbit we see different constellations, different view of the sky. And of course the sun appears, as we look through the sun appears in a given constellation. So it appears as the sun is progressing through the constellations. And the sun is migrating eastward. Why is that? Because as the Earth goes around the sun, you think about it, the sun is moving the opposite way, which around the Earth, which is eastward. So when we move from here to here to here, if you think about where you have to look to see the sun, you're looking more and more toward the east. And as we wrap all the way around, we keep looking more and more toward the east to see the position of the sun. Or another way to think about it is, as you draw a line through the sun, this is the location of the sun on the celestial sphere, on the ecliptic, and progressively as the Earth goes around, you're seeing the sun progressing in different locations. So the sun is migrating along this path, and this path is an eastward path from the point of view of the Earth. So hopefully I haven't confused you too much. At the same time, the constellations, since the Earth is moving this way, it's easy to see that the constellations are moving the opposite way. They're moving westward. Okay, so you look at Ophiuchus, and as we move around like this, Ophiuchus seems to be going this way, and that's a westward migration, from the point of view of Earth. So the constellation the sun appears in, they're defined as the zodiacal constellations, and they keep moving, they keep migrating. And so where the sun is on a given date is easily understood in this way. So with that as a background, we can understand the zodiac, which is derived from the Latin zodiacus, which comes from the Greek meaning circle of animals, because as we are at different dates, we're lined up with the sun is lined up with different constellations that are associated with animals, as you may be familiar with the horoscope predictions. And basically what it all boils down to is that when you were born, that where the sun is located, what constellation the sun is located in, has something to do with your future, apparently. It kind of makes sense. In antiquity, the sun, well, even in current times, the sun is the giver of life in a very real and significant sense. But with the sun being so important, where the sun is when you were born could conceivably have something to do with your future fortune or misfortune, for that matter. And of course, the horoscope is usually filled with lots of fortune, right? So that's kind of nice. Well, let's discuss the zodiacal signs a bit and the effect of precession on the signs. And it all pertains to what's called the precession of the equinoxes. So what is shown here is the Earth and the celestial equator, the celestial sphere encompassing the whole thing, the ecliptic, and here's the 23.5 degree tilt. And because of precession, we have this precessional circle that the North Celestial Pole migrates around. Well, the celestial equator is an extension of the Earth's equator, so it's kind of fixed or locked to the Earth's equator. Well, as precession takes place, since the celestial equator forming the equatorial plane is intersecting the ecliptic, forming the ecliptic plane, this whole equatorial plane of the celestial equator is rotating around. And so this crossing point migrates as time goes on. So the rate at which this happens is about one whole sign in 2,000 years. Well, the whole zodiacal system has about a 2,000 year history, and all the way back then, the crossing of the celestial equator and the ecliptic took place in Aries. Now it's in Pisces, and at about the year 2600, it's going to move into Aquarius. So as the thousands of years progress, your sign is actually migrating through the various constellations. So what sign are you really? Are you really what it was originally designated as, or what it currently is? Because that's changed by one whole sign. So how much basis do you want to put on your zodiacal sign and the predictions that the horoscopes use pertaining to it? Being a good scientist, I have to say that all tests done to date have shown that the astrological predictions from the horoscopes based on when you were born are indistinguishable from chance probabilities. You'll also notice that they are very general when you read them and tend to be very positive as well. So I don't want to take away any of your good feelings or the good prognoses for your future, but I'm just the messenger. And now let's take a look at a visualization of this precession with an animation. So let's get a visualization of how the precession of the equinoxes takes place. So here's the sun against the background stars, and the celestial equator expanded to intersect with the ecliptic, and that is the first day of spring, March 21st, the vernal equinox there. And we'll see now with the sun in this particular viewing at the winter solstice how this spring equinox rotates or precesses around the sky. And therefore that marks the first day of spring, March 21st, which so you can see that March 21st is occurring when the sun is lined up with different constellations. This has significant implications for your zodiacal sign. Your zodiacal sign is changing. In over 26,000 years, it moves throughout all the various signs. And now we'll shrink this down and show how the North Celestial Pole migrates from Polaris, where it is now, over 26,000 years throughout various points in the background stars, and then back to Polaris again. So hopefully that makes a little bit of sense, and that about covers it. How do the rest of the planets play into this? Well, the planets are basically in the same plane as the ecliptic, or at least very close. So here we see the Earth. The Earth's motion around the sun really marks the ecliptic. But all the other planets, as you can see in this graphic, these other planets are very close to the same plane, lying along the same plane as the ecliptic. So there's a band, here it kind of shows it, a band with plus or minus certain angular degrees. Each planet is a little bit different. But within this band, you will see all the planets. So the planets will show up in the constellations, the zodiacal constellations, as the sun does, but in slightly different areas. So plus or minus a few degrees north and south encompasses the region in which you will observe all the planets that you can see.